Okay, so this is applications 2 tutorial 2, applications tutorial 2, PQ question 5, practice question 5. So we are considering the shaded rectangle and the area between the graph and x-axis. Okay, for n is greater than equals to 1. Okay, so the graph that we are looking at, okay, so actually it's not shown here. Okay, the graph is not shown here. We need to show that the graph. Okay, this is the question that we have. So this is our graph here. This one is x. This one is y. This is our function. Our function here is y equals to 1 over square root x. Okay, and by considering this shaded triangle rectangle, right? Okay. Okay, the area of the region between the graph and the x-axis, show that 1 over square root n. We need to show that 1 over square root n is less than 2 of root n minus root n minus 1. Okay, how do we go about doing this? Okay, so this is n minus 1. So okay, so here the question is this is given to be n minus 1. This is given to be n. Alright, how do we show that 1 square root n? Okay, so here, if you were to observe, right, one of the things I'm going to do is I can also find, okay, let's say I use this in red, right? I can find this area, right? Okay, I can find this area, right? Okay, so what? Let's say if I try to find this area, I'm integrating from n minus 1 onto n 1 over square root x. Okay, this is an integration question, so naturally you'll be thinking of integration, right? Then you have what do you get? You get so solving this. Okay, you can solve it for yourself. You get 2 square root x, right? 2 square root x from n minus 1 to n, and that will give you 2 square root n minus square root n minus 1. Okay, right? So you see, oh, I'm starting to get the right hand side of the inequality. What about the left hand side? What is this? Okay, so remember they told you that you need to consider the shaded rectangle. So what's the area of the shaded rectangle? It's let's look again. This is the black color portion, right? What's the area of the shaded? Okay, so what is the width? The width is what? 1 unit, right? What is the height? Can we see the height? Let's say we focus on to see the height of the rectangle. Let's focus on this coordinate. Okay, can we see that the height here is nothing but 1 over root n? Okay, how do you know? Because you just look at this coordinate. The coordinate is like this is n, this is n, right? This is n. The y coordinate, because it's y equals to 1 over root x, so the y coordinate is like 1 over root n. And here the y coordinate also helps to give you the height of the rectangle. So the area of the black rectangle is nothing but 1 times 1 over root n. Okay, and now I look at this and I look at this. Why is this smaller? Okay, because so why is the 1 over why is this 1 over root n less than 2? So you can see it. If you observe this portion, can you see that the rectangle here is less than the area underneath the curve? This is less than this area, right? The black is less than the red, right? Can you see this black color portion is less than the area under the curve? This is just a rectangle. Okay, there is still some spare area here, right? So it is very obvious by comparing the area to the black versus the red, right? You can see that this is less than this. Okay, so how do we present that? Okay, so all we need to do is just say that okay, as the rectangle is underestimated, or you can say it's within the area of the curve. Okay, we have 1 over square root n to be less than integral of n to n minus 1 over root x dx, and this is this is equals to 2 root n minus root n minus 1. Okay, that is for part 1. Now part 2, deduce. Okay, deduce means what? You actually use the earlier portion. How do you use show that 1 plus 1 over root 2 plus 1 over root 3 all the way up to 1 over root n is less than 2, right? So here we can deduce means we use the earlier portion. In general, right, you know that from part 1, this is true. You know that this is true. Alright, so you think about it, right? Okay, so you have 1 plus 1 over root 2, 1 over root 3. So 1 over root, 1 over root, 1 over root. Hey, look, hey, I have a 1 over root n here. What does it mean? Can I let n be a certain value? So if say we think about letting n to be equals to 1. Let's say if I let n equals to 1, then this is like 1 over root 1 is less than 2. 1 minus 0, right? Since root 1 minus 1 is 0. How about if I let n to be 2? Then 1 over root 2 is also less than 2 of root 2 minus root 1. How about n equals to 3? Then 1 over root 3, this will be less than 2. Root 3 minus root 3 minus 1 is 2, right? How about n equals to 4? Okay, so on and so forth. You can say you have 1 over root 4 less than 2 root 4 minus root 3. Okay, so you can keep going on to the point where I have n, then this is, you can see we are doing a generalization. So why am I doing this? So the idea here is that when we compare individual values of n, we have an inequality. So how do we achieve the answer in part 2? Okay, you can see, right, summation. Now if you have learned sequences and series so far, you know actually we are going to do a summation. So all I need to do is, if you see individually they are all, this is less than this, this is less than this, this is less than this. If I were to sum up this portion, can I say it's also less than this? Okay, so if I sum up my left hand side, I have 1 over, this is 1 plus 1 over root 2 plus 1 over root 3, okay, so on and so forth, right? Plus 1 over root n. This is less than, okay, so I have 2, 1 minus 0. So if you observe, right, okay, you learn method of difference, this is something like method of difference. See, cancel off, cancel off, cancel off, cancel off, cancel off. What am I left with? I'm left with 2, okay, all the multiples of 2. I'm left with 0, I'm left with root n. So I can see that, oh, I'm just left with root n. That's all. And so that solves your part 2. That solves your part 2. Okay, part 3. What about 1? How do we show? 1 over square root n is greater than 2 square root n plus 1 minus root n. How do we do this? Okay, this one, right, is another, you need to use another trick. Okay, so how do we show that 1 over square root n is greater than 2 root n plus 1 minus root n? Okay, so here, right, if we need to consider, okay, so we consider again shaded. Just now we were doing something like this, right? Okay, it's on the rectangles below, right? Okay, let's see, I go change. Let me do it this way. Now I put the rectangle on top. This is y, this one is x, this is y equals to 1 over square root x. Okay, then what's the area of the shaded rectangle? So again, if this is n, I call this n plus 1. Okay, you will see why I will purposely do this, because show also, right? Okay, so I'll purposely do this because I see a n and n plus 1 here, so I put n and n plus 1. That's how I know lah. Okay, what is the area? Then what is the area of this rectangle? So this portion, I get the height from here. Okay, if this is n, 1 equal 1 over, so it's 1 over root n, right? Okay, see? So that means, right, the height of this rectangle is 1 over root n. That means the width is 1. That means, right, the area of this rectangle, the red portion, the red rectangle is equals to 1 over root n times 1. That's the area of the red rectangle. Then why is it greater than this? So what do you think this can be? After doing part 1 and part 2, you can suspect here and here. How am I going to get this inequality? This is nothing but the integral. Okay, so you can see that this is nothing but the integral. So this is, okay, let's say I use blue. This is the integral from n to n plus 1 over root x dx. Okay, and you can see if this is the red rectangle. Now I'm using the blue. The blue rectangle is, we are talking about the area. This one is referring to the area under the curve. Can you see that the blue portion is lesser than the black rectangle? The black rectangle. Can you see, right? Okay, so that's why the next step is say clearly. Okay, clearly the rectangle is above, or we can say it's overestimated. Has overestimated the area of the curve. Hence, 1 over root n is greater than 2 root n plus 1 minus root n. And you say should. Right, this is for part 3. Okay, how do you deduce then? You can see actually part 1 and part 2 and part 1 part 2 together and part 3 part 4 together are similar. Okay, so you have this idea. From part 3 you have this idea. You know that 1 over square root n is greater than 2 square root n plus 1 minus root n. Okay, so the idea comes exactly the same as part 4. Okay, it's the same as part 2, sorry. Can you see what I do? I let n equals to 1, n equals to 2, n equals to 3. So it's the same old grandmother story. I just let n equals to 1. All you have 1 over 1, right? Greater than 2. This one is 2. This one is 1. Come out already. Okay, so square root 2, square root 1. Okay, I'll purposely write in column form so you can see like I'm doing some sort of a method of differences. So this is n equals to 2. 1 over square root 2 greater than 2. N equals to 2, right? So n plus 1 square root 3 minus square root 2. Okay, n equals to 3. Okay, so if I'm going too slow, you can always fast forward the video. This is 2 square root 4 minus square root 3. N equals to 4. This is 1 over square root 4 greater than 2 square root 5 minus square root 4. Okay, so I go on. You can see when n equals to n, for example, this is 1 over square root n greater than 2 square root n plus 1 minus square root n. This is like the total. Okay, this one is let's ignore this. So again, I sum up all the left side, I sum up all the right side. On the right side, easy to sum. Cancel. Can you see cancel? Cancel, 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 cancel. I'm left with square root n plus 1. Left with this. On my right hand side, I'm left with 2 square root n plus 1 minus square root 1 is just 1. On the left hand side, I'm left with 1 plus 1 over root 2, 1 plus 1 over root 2, plus 1 over root 3, plus 1 over root 4, plus dot 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 dot. You can see 1 over square root n. So this is the proof of part 4.